Welcome, geometry students, to the homework help video, page 254, numbers 10 through 22 all, 24 through 30 all, and 34 and 35. Please have your books open to page 254. Have your homework out, your pencils out, calculators, everything you need. And let's see if we cannot give you some help on this homework assignment. All right, let's take a look at numbers 10 through 13. 10 through 13. The directions read: tell whether the side is included or not included between the given angles. Tell whether the side is included or not included between the given angles. All right, let's start with number 10. Here we go. Let me slide this over. We'll go right there, and here we go. Angle B, so here's angle B right here, and angle BCA. So B, then C, and then A. So this angle right here, actually I'm going to use dots, okay? So we'll put a dot here and a dot here. Now, is AB included or non-included between those two angles? Now look, if we're dealing with this angle here and this angle here, then the included side has to be this side right here that's between those two angles. And the side they're asking us about is AB. So is AB between those two angles or included between those two angles? No, it is not. So we say that AB is not included. Okay? All right, let's take a look at number 11. The angles are BAC, so here's BAC, so put a dot here, and then BCA, we'll put a dot here. And the side we're talking about is side AC, this side right here. Now, is AC between those two angles? Sure it is. You have this angle right here, and then the side, and then this angle right over here. So yes, AC is included between these two given angles right here, definitely. All right, number 12, angle DAC, so D, then A, then C, so this angle here, and angle D. So angle D right here. And the side we're talking about is AC. So here's AC. Is this side AC between these two angles? No, it is not. So we say that AC is not included between the two given angles. Not included. Let's take a look at 13. Angle CAB. So here's C, then A, then B. So this angle here. And here is angle B right here. And the side they want us to look at is side BC. Here's BC. Is BC between these two angles? No, it is not. So we say that BC is not included between the two given angles. All right? Okay, let's continue on. The directions for 14, 15, and 16 read as follows. Tell which postulate or theorem you would use to show that the triangles are congruent. Explain your reasoning. Now what we've learned so far is side, 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 angle, side, angle, angle, side, and angle, side, angle. Now I'm going to go ahead and copy these just so I have that for future reference during this video. Hold on one second. Okay, there we go. Now let's take a look at this and see what we have. Notice that we have an angle, and then a side, and then an angle, congruent to an angle, and then a side, and then an angle. So we have angle, side, angle in this triangle, congruent to angle, side, angle in this triangle. So which one of these would you use to prove that these two triangles are indeed congruent? Angle, side, angle. Let's take a look at 15. Here we have an angle right here, and then an angle, and then a side. So we have an angle, then an angle, and then a side, congruent to an angle, angle, and then a side. Do you see that okay? So we have an angle, angle, side in one triangle, congruent to angle, angle, side in another triangle. So we would use angle, angle, side, angle, angle, side. All right, number 16. Now, we're going to go back to what we did yesterday, which I think personally, if I can find where it's at here, I think personally is very helpful. I'm going to split these two triangles up. And now let's go ahead and fill in what we know. We know this is U, R, S, and this is U, T, S. We know this angle is congruent to this angle. We know this angle is congruent to this angle. And look, they share US. They share a common side. So we know this side is congruent to this side. So we have angle, side, angle, congruent to angle, side, angle. So how would you prove that these two triangles are congruent? Angle, side, angle. All right. Let's continue on now to numbers 17 through 22. Number 17 through 22. The directions for 17 through 22 state, does the diagram give enough information to show that the triangles are congruent? If so, state the postulate or theorem you would use to prove that the triangles are congruent. Okay, let's start with number 17. Notice I have a side, angle, side, congruent to a side, angle, and a side. So yes, I can definitely state that these two triangles are congruent, definitely. And I can do that by using side, angle, side. I have a side, angle, side in one triangle congruent to side, angle, side in another triangle. Okay? Number 18. Now let's take a look at this very carefully, okay? First of all, I would like us to somehow, if at all possible, I'd like to white out this line here in the middle just for a second, pretend it's not there. And the reason I want to do that is I want us to pretend that we have just a really big triangle right there. Okay, so first of all, would you do that for me? Notice we have a really big triangle right here. I'm going to highlight it for you. Right there, a really big triangle. Now, remember what we learned about a week and a half ago? Whenever a triangle has two congruent angles, like this, then their opposite sides are congruent. So, if this angle here is congruent to this angle here, then go straight across to this side. That means that this side here goes straight across to this side, and this side here are congruent. So, I know that I can state that this is congruent. Put one slash. I know that side is congruent to that side. Now I'm going to go and take my eraser and erase this white line. There we go. So now I know some more information. Now I know that I have a side here congruent to this side over here. Also notice something else. Notice I have an angle here congruent to an angle here. And then look at this. See how I have a right angle here? Well, we know if I have a right angle there, then I have to have a right angle here, because a straight line always equals 180 degrees. So if this is 90, this has to be 90. So look what you have, guys. Look, you have in this triangle here, in this triangle right here, you have angle, and then side. Do you see it? Angle, angle, side, congruent to angle, angle, side. Do you see it? Look at it again. Angle, angle, side, congruent to angle, angle, side. So yes, we can definitely state that these two triangles are congruent by angle, angle, side. All right, number 19. Here we go. Now, remember, whenever you have two lines that intersect like this and like this, vertical angles are congruent, so this angle and this angle is congruent, and this angle and this angle are congruent. So please don't forget that, okay? So right away I see that I have two lines intersecting, so I know for sure that this angle here is congruent to this angle here. So look what I have, students. It's not that hard. I have an angle, then a side, then an angle. Let's look at it again. I have an angle right here, then a side, and then an angle, okay? congruent to an angle and a side and an angle down here. Okay, so if you look at that, what I basically have is, yes, these two triangles are congruent, and the reason that I can say that is angle, excuse me, that's wrong and I apologize, angle, side, angle, angle, side, angle. All right, let me grab a quick drink of water here. And let's move on now to number 20. Number 20. Okay, number 20. Let's see what we have here. Well, notice, students, that we have an angle here that would definitely be congruent to an angle here. Okay? So look what we have. We have side, then angle. Do you see it? Look at it again. We have a side, then an angle congruent to a side and an angle. So everybody see that? So what we have is side, angle. And we've never learned any theorem or any proof that's SSA. In fact, let me do this real quick here. Okay, it's not working. Well, I had those cut and pasted, but remember, the only thing that we've learned is side, angle, side, wow. Side, angle, side, angle, and angle, side, okay? There is no theorem or postulate or corollary that's going to teach side, angle to prove that triangles are congruent. It does not exist, okay? So no, with the given information here, we cannot state for sure that these two triangles are congruent. Now, they could be congruent. Maybe they are, but we don't know for sure. All right, number 21. Wouldn't this be side? Look, I have a side here congruent to this side. I have a side here congruent to this side. And then don't the two triangles share this side right here? Sure they do. So put 3 marks here. So I have 3 sides of one triangle, 1, 2, 3, congruent to 3 sides in another triangle, 1, 2, 3. So yes, sorry for the yawn there. Yes, we definitely could state that these two triangles are congruent, and the reason would be side. All right? Let's move on now to number 22. Now, the only thing we really know here, let's be careful. We know we have a line here and a line here, and we know they're parallel, okay? And then we have a transversal cutting those two parallel lines. So we know this angle here is congruent to this angle here because alternate interior angles are congruent. All right, that's not easy to see, but that's the truth, and that's how it works. So I do know that this angle here is congruent to this angle here. Now notice the bottom triangle here and the top triangle share a side. They share this side here. So we know that we can say that NL is congruent in both triangles because both triangles have NL. They share a side. But students, that's all that you have. You have nothing else. And actually, I apologize. I marked this wrong down here. It's totally my fault. I said this angle, and that's so wrong, and I'm sorry. It's this angle right here. There we go. And then this side here. So that's all we have. We have angle and a side, and then angle and a side. And I hope I don't bore you too much, but to be honest with you, probably good for you guys to see this split up. So we have this angle here congruent to this angle here, and this side congruent to this side. So we have angle side congruent to angle side, just AS, or SA, however you want to look at it. There's no way to prove that two triangles are congruent just based on that. So no. Now, could these two triangles be congruent? Definitely, they very well could be, but we don't know for sure if they are. Okay, so no, we cannot state for sure that these two triangles are congruent. Now, 24, 25, and 26. Determine what congruence is needed in order to use the indicated postulate or theorem to show that the triangles are congruent. So for example, in number 24, they want us to use the angle, side, angle. So look, we have an angle here, and then an angle here. So in order for us to use angle, side, angle, what other part of the triangle has to be congruent? Well, guys, if it's angle, side, angle, it has to be this side right here, congruent to this side here, right? Because look what we want. We want angle, side, angle. So here's angle, then side, and then angle, congruent to angle, and then side, and then angle. So what we're looking for here, in order for us to have angle, side, angle, then we have to know that this side here is congruent to this side here. Once we know that, then we can use angle, side, angle. So let's see what the answer is, if we can get this to work. AC has to be congruent to FD. AC congruent to FD. Okay? All right, let's try number 25. Here they want us to use angle, angle, side. Now come on, think about this, guys. Angle, angle, side. That means I need two angles. My pen's not working. There we go. Two angles and a side. Now I have an angle and I have a side. I just need one more angle. Well, students, come on, think. It wouldn't be this angle here because that's angle, side, angle. And we don't want ASA, angle, side, angle. We want angle, angle, side. But how about this? If I marked this angle here congruent to, let's see, this angle here, then I would have angle, angle, and then a side congruent to angle, angle, then a side. So what am I missing in order to use the angle, angle, side? I'm missing K is congruent to Q. I have to know that angle K is congruent to angle Q. Let's take a look at 26. They want us to use the angle, side, angle postulate. Angle, side, angle. Now, think about this. If we split these two triangles up, we know they share a side right here. Okay? We can see that. In fact, very quickly, I'm going to do what I almost always do. All right, here we go. W, X, Z, X, Z, Y. This angle here is congruent to this angle here. And this side here is congruent to this side here because they share a side. So what are we missing for angle, side, angle? Well, here's angle, then side, and then angle. Here's angle right here, angle, then side, and then angle. So we're missing X and Z being congruent to each other. Those two angles have to be congruent to each other if we're going to use angle, side, angle. Angle, side, angle. All right, that's number 26. Let's see what we have next here. Number 27. The directions for 27, 28, 29, and 30 read as follows. The triangles below show a step in folding an origami seal. State the third sequence needed to prove that ABC is congruent to ABD triangles. And then they give you a given in each one, and they tell you what theorem to use or what postulate to use. So you have to tell what's missing to be able to use that theorem or postulate. So here we go. Let's try number 27 here. Now on number 27, let's go ahead and take our given and let's write on the triangle. We are given angle CBA, so put a mark here, is congruent to DBA, so put a mark here. And then we know that BA is congruent to BA, which is obvious, so this line right here, okay? And I really get tired of doing this, to be honest with you students, but I just feel like it's important to do. So if you get tired of this, I'm sorry, but I do feel like it's important to split these triangles up. And you can tell I get decently sloppy. I'm not trying to, well, that's fine, we'll just do that, that's fine. I'm not trying to make it perfect. I just want you to see the two triangles split up. Okay, here we go. CBA. B, A, B, D, A. Now, we know that CBA, this angle here, is congruent to DBA, this angle here. We know this side is congruent to this side. Now, they want us to use the angle, side congruence. Angle, side. Well, look, I know it's not going to be this angle here because then I would have angle, side, angle. However, if I said this angle here is congruent to this angle here, then look what I have. I have angle, side, congruent to angle, side. So there we go. So what I'm missing is angle C is congruent to angle D. That's what I'm missing. All right, number 28. I think I need to go back here real quick. I think it'd be very helpful if I just went ahead and did this for each problem and save time and pulled these halves down here. So that's what we're going to do. So give me a second. And there we go. So, given that angle C, and this is CBA, BAD, angle C, put 1 mark here, is congruent to angle D. Put 1 mark here. AC, put 1 mark here on this side, is congruent to AD. This one here. Now, we want to use angle, side, angle. So here's an angle. Here's my side. I definitely would not want to use this angle here because that would be angle, side. And I want angle, side, angle. So if I want to use angle, side, angle, what part am I missing out of angle, side, angle? Well, it's this right here. This angle here, 2 marks, is congruent to this angle here. Okay? So it would be angle, side, angle, congruent to angle, side, angle. Now be careful calling this angle A. You say, well, I want this angle here congruent to this angle here, so angle A is congruent to angle A. Be careful. Be careful. You've got to use your original picture. I know that we split it up here so we can see it easier, but look, when you say angle A, we don't know what angle you're dealing with. So really what you've got to say is angle CAB, which is this angle right here, CAB. So angle CAB is congruent to angle DAB, angle DAB. And that's exactly right, because you need to have this angle here congruent to this angle here. All right, number 29. Now, let me go back here. Forgot to do this, and I think it's just a little, doesn't save a lot of time. It saves a little bit of time doing this. All right, very good. All right. Okay, given C is congruent to D, so here's C congruent to D, and CAB, so CAB, this angle here, is congruent to DAB, so DAB. And they want to use the angle, side, angle congruence. So what part of the angle, side, angle are we missing? Well, we know we have an angle here and an angle here, and we know it's not angle, angle, and then side. It's angle, then side, then angle. So angle, side, angle. So we need this side right here between the two angles to be congruent to this side here, which is between those two angles. So what I need is CA is congruent to DA. CA is congruent to DA. That's the side we're missing, okay, or the part that we're missing. All right, number 30. And again, I forgot to do this. Let's grab these triangles quickly. Pull them over here. And here we go. Angle C is congruent to angle D. There we go. AC, this side here, is congruent to angle AD here. And now they want us to find the missing part. If we wanted to use side, angle, side postulate, what part are we missing out of the side, angle, side? Well, look, students, I have a side right here and then an angle. So if I just knew this side right here, I could say side, angle, side, congruent to, here it is, side, angle, side. So here's my side, side, angle, side. I wish I knew that CB was congruent to BD. That would be side, angle, side. So what I'm missing is CB congruent to DB. CB congruent to DB, okay? Which is this side here congruent to this side here, okay? And that's what we would need to know to use side, angle, side. All right, 2 problems left and we're finally done. Numbers 34 and 35. So here we go. Numbers 34 and 35. Now, on numbers 34 and 35, and here's 34 in front of you. If you'll look in your book, you'll see this. I'm not huge fans of doing proofs like these because I'd rather just have you do the whole thing on your own, just learn the hard way. But this is all they had in this lesson, so that's okay. We're going to go ahead and do this just step by step, and I'll help you, okay? All right. Notice, first of all, here's our given. They've given this to us, and they want us to prove this right here. Now, they've kind of written steps down for us and reasons, and so we've got to figure out what's missing. For example, for number 1 right here, GF is congruent to GL. There's nothing to do. They already tell us the reason. It's given. But look at step 2. FH is parallel to LK. They want you to tell the reason. How do we know? How can we state that? How do we know that? Well, look. Is it not part of your given? FH is parallel to LK, right? Here it is. Here it is. So there we can just say it's part of our given. Now I know I taught you to write all of that as step 1, and most of the time they will, but that's okay to do it like this also. So that's your given. Now, how can I state that angle F is congruent to angle L? How do I know that for sure? Take a look at it. Angle F is congruent to angle L. That's the reason we're going to write over here. How do I know that angle F is congruent to angle L? Well, let me show you how we know that. Okay, watch. See this arrow? That means this line here is parallel to this line here. Do you see it? And now see this line right here? That's called a transversal. Okay? So there we go. Now, remember what we learned about parallel lines cut by a transversal. I have half a notion to go like this, and then go back, and then go back, and back, and do this. I don't think that I might be able to. I'd like to show you something here. You know how I just highlighted all of that? Well, it'd really be good for you guys to see this. There. All that I did was this. Let me slide this back up here. All that I did is I just highlighted this parallel line and this parallel line and this transversal. And then I pulled it over to another page and I rotated it. Remember how you've learned that alternate interior angles are congruent? That means this angle here is congruent to this angle here. Do you remember that? Now watch what happens when I quickly take this and flip it back around. Please watch this carefully. Watch. There. That's what you have right here, do you not? Sure you do. You have this angle right here congruent to this angle here. Let's go back and look at it again. Right here. Right here. Okay? Now, I'd have to rotate it a little. Maybe I rotated it the wrong way. Maybe I should have rotated it that way. I'm not sure. But either way, the reason that I can state, yeah, it would be this right here. But the reason that I can state this is because alternate interior angles are congruent. So here it is right here. Alternate interior angles are congruent. Alternate, I know it's cut off here, students, but you can use your imagination. Alternate interior angles is why. Okay? All right, let's move on now and take a look at step 4. Now look at step 4. Notice on step 4, instead of asking you to find the reason, they want you to find the statement. So let's go to the reason. Vertical angles theorem. Or in other words, I allow you to write vertical angles are congruent. vertical angles are congruent. So let's look up here. What two vertical angles could they be talking about? Would it not be this angle here congruent to this angle here? I'm sure it is, students. Of course it is. Of course it is. So I'm going to go ahead, I'm going to use some red so this stands out a little better here in my diagram. So give me a second to do that. So I already showed you how this angle here is congruent to this angle here. We already know this side here is congruent to this side here. And now I'm going to put 2 marks here and 2 marks here because that's what they want us to see here. They're saying vertical angles theorem. That's their reason. Vertical angles are congruent. So what would I write over here? Which two angles are congruent because they're vertical angles? Well, angle HGF and angle KGL are congruent. So let's quickly take a look at this. And there it is. Angle HGF and angle KGL are congruent. And now look, now we have stated triangle FGH is congruent to triangle LGK. Now how did I know that? What is my reason for saying that? Well look guys, we have angle, side, angle, congruent to angle, side, angle, and another triangle. So the answer is very simply angle, side, angle. Alright, ASA. That's it. Okay, one more problem and we're finally done. So congratulations to you guys. Last problem and we'll see how you do on this, okay? All right, first of all, they want us to give our given, okay? Now, here's our given right here. And here's what they want us to prove. Now, I want to show you something. Do you see how there's 3 things they've given to us in the given? I like to put all those in step 1 and just write the word given once. But if you'll look, they've split all 3 of these up into the first 3 steps. Boom, boom, boom. And how do I know that? Because it says given over here. So right here, AB is perpendicular to AD, AB is perpendicular to AD. I know that's going to be given. It has to be. It's given. And then look right here, DE is perpendicular to AD, DE is perpendicular to AD. So the reason I can write that would also be given. Now let's go back up to number 1. Out of all 3 of these givens up here, which one has not been listed yet? Well, this one right here. So I'm sure that's what they put right. It says given, so I'm sure that's what they put right here. Yep, they sure did. BC is congruent to EC. BC is congruent to EC. Okay? Now, let's take a look at number 4. Number 4, they're saying angles A and D are right angles. Angles A and D. Now, what reason could I state? All that I know, here's angles A and D. All that I know in my given is AB is perpendicular to AD, and I know that DE is perpendicular to AD. That's all that I know in my given. That's all they've given me. Well, students, isn't that all you need to know? I mean, think about it. If you know that 2 lines are perpendicular, then you know that they're going to form right angles. Now you could put a couple different reasons here that I would accept. First of all, if you said A and D are right angles because definition of perpendicular lines, I wouldn't have a problem with that. I really, really wouldn't. But here's another one too. We learned a postulate or theorem or corollary. I forget which it is, but it stated perpendicular lines form right angles. Perpendicular lines form right angles, okay? So either way, you could just put definition of perpendicular lines, or you could write that out. Either way is fine. Now let's take a look at step 5. Over here in the reason, they're saying we put something here, and the reason we put it is because right angles are congruent. Now think about that. Here we stated that A and D are right angles. Now that we've stated that they're right angles, look at step 5. Right angles are congruent. So if we're saying right angles are congruent, then that's definitely what we put over here. We took our 2 right angles, A and D, and we said they're congruent. So we said angles A and D are congruent. Angle A is congruent to angle D. And how did I know that? Because what did I just say in step 4 angles A and D were? They're right angles. And don't we have a theorem or a postulate or corollary that states right angles are congruent? Yes, we do. We learned that probably months back. Right angles are congruent. Now, let's start marking some things here on our triangle so we don't lose track of everything. So far, we have our given, which should already be on here. So CB is congruent to EC. So yes, we have this, being marked with this, and we know that these two angles are right angles. Okay. Now, look at step 4. Angle ACB. Where's ACB? Oh, it's right here. Look, guys. ACB. So this angle here with a dot is congruent to angle DCE, this angle with a dot. So in step 6, they're stating that this angle here is congruent to this angle here. Do you see that? What reason could we give? They're right. Those two angles are congruent. What reason could we give? Well, notice we have two lines that are intersecting. Whenever two lines intersect, we have vertical angles. And we know that vertical angles are congruent. Okay? Vertical angles are congruent. We know that when two lines intersect, like this line and this line, we know that their vertical angles are congruent. So we know that this angle here would be congruent to this angle over here. Now they're ready to state that triangle ABC is congruent to triangle DEC. Okay, now how can they state that? Looking at your diagram up here, how could they state that these two triangles are congruent? Angle, angle, side, angle, side, angle, side, angle, side, 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 side. How could we state that? Well, it looks like to me we have an angle. We definitely don't have angle, side, angle, because we would have to know that this side here was congruent to this side here, and we don't have that. So we know it's not angle, side, angle. How about angle, angle, and then side? Angle, angle, side, congruent to angle, angle, side. Okay, do you see that? So angle, angle, side in one triangle is congruent to angle, angle, side in another triangle. So how can I state that these two triangles are congruent? Angle, angle, side. Angle, angle, side. Guys, this is not easy math. I know it's going to be difficult for you. I know you just got to work hard and keep pushing on. But please continue to do so. I hope this homework help video was a help to you. Please call me or email if you have any questions.